The fundamental theorem of calculus is a very important sounding name. It is a very important theorem. It connects the idea of definite integrals and just integrals or integration in general back to derivatives, which has been our topic for most of this semester. According to the fundamental theorem of calculus, if some function, capital F of x, is a function where capital F prime of x is equal to f of x, then the integral of lowercase f of x, evaluated from a to b, is equal to capital F of b minus capital F of a. In this theorem, capital F of x is referred to as the antiderivative of lowercase f of x. That is, if we differentiate capital F of x, we get lowercase f of x. If we take the antiderivative of lowercase f of x, we would get back to capital F of x. So the idea of an antiderivative is just the idea of working that derivative process backwards. And another way we refer to that is that we refer to capital F of x as the indefinite integral. So distinguished from the definite integral, we refer to that as the indefinite integral of lowercase f of x. What this theorem is telling us is that we're still building towards this, but once we get to the point where we can evaluate a definite integral, what we do is find the antiderivative of a given function. So we work the derivative process backwards and evaluate that resulting function at the lower bound and the upper bound for x and take the difference of those two results. We're going to keep taking this in small steps as we work towards this process of being to evaluate a definite integral from beginning to end. Ultimately, what we're going to want to be able to do is take a function r of x and find its antiderivative or its indefinite integral. But instead, for right now, what we're going to do is see how, starting with the indefinite integral or starting with the antiderivative, we can find what that original function is that we wanted to integrate. In order to do that, we take the expression on the right-hand side of this equation and we take its derivative, meaning we'll get negative 2 times negative 3x to the negative 4th, or 6x to the negative 4th. That expression, that function, is equal to r of x, meaning the indefinite integral of 6x to the negative 4th dx integrated with respect to x is equal to negative 2x to the negative 3. We're going to build up to that process, how we can work those indefinite integral problems. But for now, we're still just going to work on, given that indefinite integral, finding the original function we would have been integrating. So to do that in example 5, we'll take d over dx of negative 5x squared plus the natural log of x plus 4, which would give us negative 5 times 2x plus 1 over x plus 0, just as a placeholder. So we would get negative 10x plus 1 over x. That is, the antiderivative of negative 10x plus 1 over x is negative 5x squared plus the natural log of x minus 4. And again, we'll get to working those problems in sort of the right direction. Now we're still working in backwards. To find s of x, in example 6, we would take the derivative of negative 3x cubed times the natural log of x, which requires an application of the product rule. which will give us negative 9x squared times the natural log of x. And we can go ahead and change this to minus 3x cubed times 1 over x, or negative 9x squared times the natural log of x minus 3x squared. And then in our last example, we've got an application of the chain rule. In order to find the original function m of x that we would have to integrate to get this result, we'll take d over dx of negative 4 times negative 3x to the 4th plus 5x cubed to the 5th power, which will give us negative 4 times 5 times negative 3x to the 4th plus 5x cubed raised to the 4th power times the derivative of that interior function. And the derivative of that interior function will be negative 12x cubed plus 15x squared. Again, in each of these problems, we're just trying to work on reinforcing this idea, this connection between indefinite integrals and derivatives. And as we keep moving forward in later topics, we'll get to the point where we can show that the indefinite integral of negative 20 3x to the 4th plus 5x cubed to the 4th power times negative 12x cubed plus 15x squared is in fact equal to this expression that we started off with.